Hi fellas, I just solved a tough job that took me a long time before I could find solution to it. Alright, so this is a motherboard. Look at the board view here. Let me zoom. Can I zoom in from here? Alright, good. So here's board view. Look at the top here. Can you see? So this board is Pavilion 15. The number is okay at the top. Look at the top there. DAY11AM. This is E0. Now remember I've okay dealt with this motherboard before. Same charging problem. Okay, same charging problem. So on this, it appears that this type of board has charging problems often come up with this system, and it comes in different form. Okay, so looking at this, initially the charging problem that it has was that this part, okay, was that this part come here. Zoom in. Let me zoom in. Respond, my friend. Good. So the problem that it has was that the sensor, okay, so one of these line was broken. Yeah, this sensor here. So one of the line here is broken. So while the other side, one side we from this charging IC, it will connect here. It comes here, but the other side of it does not work. Okay, so hence it does not charge. Though the system works on battery, but it does not charge. All right, so I made a jumper from here straight to this, so it worked. So another problem now comes up, okay, that it stopped charging. Same motherboard stopped charging. So I ordered, I thought it was this thing. Okay, I read and check. Wow, as if I thought it was the charging IC. This charging IC, I thought this charging IC was at fault. So I placed an order for charging IC. It arrived. Let me see if I can still find the charging IC. So this good. Yeah, here is it. BQ24738H. Yeah, BQ24738H. Yeah, yeah. Can you see? So that is the charging IC. So it was okay. The order came. I changed first, second, nothing. So what happened was that this time around, for this FET to open, okay, this PK20, for this FET to open, yeah, this FET for it to open, a 25 volt has to come AC drive. Okay, this AC drive, that's number 4, pin number 4 on the charging IC. We come to this gate here and open, so that the 19 volts coming from the adapter will enter into the system. So this serves as a gateway. So if what happened was that instead of 25 volts, what I'm getting here was 0.8 volts. So hence this will not open. So I said, okay, I made the jumper. Okay, I connect here to this place. So this system turns on, but it does not charge. It indicates this red light. Yeah, this red light that it's charging. At that sort of time, the charging light, it will go off. So the system never charged. So I kept looking, read this part, and I checked all the pins on the charging IC. Like I put my multimeter in diode mode, and all gave me readings. All except the one that is connected to the ground. All gave me readings, and everything was perfect. What should I do? But one thing about this charging IC, there are some conditions that must be met for AC drive to be produced. And one of such condition is, number 1 is that to have 25 volts here, this, okay, 6 volt must be here. That is pin number 16. Okay, 6 volts must be present, and it must be less. It must be exactly 6 volts. That is pin number 16. That is number 1. And this pin number 16, if 6 volt is here, I got to know that yes, this pin number 16, if you read it and you are not getting 6 volt, there's high likelihood that yes, this charging IC is 40. But if there's 6 volts here, it shows that this charging IC, there is high chance that yes, this charging IC is okay. All right, so that is that. This is important. REGN, 6 volt must be here, exactly 6 volt. It must be less, it must be greater, it must be 6 volt. That is number 1. Number 2 is ACDET. We have ACDET. ACDET, it must be 2 points. Before I was getting 1.6 volt here. Okay, I was getting 1.6 volt here, so it was not enough. So as ACDET here, okay, this one is AC detection. So as AC detection here is 1.6 volt. AC OK, this AC in, it will not produce. Okay, so my AC OK here remains 0. So hence here will not produce, it will not give me 25 volts, so that it will open the FET there, so that the netting volt will be supplied into the system. So AC data is 1.6 volts. And I'm checking all this. I remove all these resistors. This PR system is 430K, PR2 and 3 69.8K. What is this one? Is 1 mega ohms. This one both 1 mega ohms, and this PR16 750K, this 127K. Everything reads fine. I remove all these resistors to check if they are 40, if one of them is 40. But so the surprise, everything they're perfect, they read, that's fine. Wow. So I check, so I check here, and I read this. I even replaced this, but I replaced these two spider this, but no, this BQ347 and still it remains the same. Okay, so while I check, I read there is a voltage comes, this number 3 comes here, and no voltage here. I think there was voltage here. Yes, there was voltage here. And when I check, what I now discover was that the problem was that, this number 1 goes to the ground. Yeah, but when I check, it does not read to the ground. Okay, and when I check a volt here, it read, it gave me a voltage which shouldn't be. Okay, which shouldn't be. And I said, so the fault lies on this. The ground to this base has been disconnected, hence this thing was floating. So hence, since the condition could not be met here, so that's why my ACDET here was, why my ACDET here was 1.6 volts instead of to give 2.7, 2.8, 2.7. Now, what gave me in that the problem definitely from this side was that I removed PR17. So immediately I removed PR17. When I removed PR17, I get 2.7 volts here. Yeah, I get 2.7 volts here. My AC OK came up, so I have my AC OK. But this AC drive remains at 0.8 volts. Hence, nothing is supplied to the system. So everything check out fine, and it's as if my this in here is having a problem. But then, since I've removed PR17, so the circuit is not complete. So I believe that this charging IC will not still work because something is missing in the system, in the circuit. So I replaced PR17, and it returned. This thing drops back to 1.6 volts. So what did I do? So I check and now focus on this. That was when I removed all these resistors. I check all this. This check out fine. Oh. So I now read this, check, there was voltage here, there was voltage here. And I say, wow, this is a gate. If gate comes here, there shouldn't be volt here. This one should come, the light should come straight down to this. So we should only have volt here, a light here, but nothing should be here. but something was here. Something was also here. So I made a jumper, okay, from the LVCD, from the EDP, yeah, from ground. So I connect to it in order for me to get the ground, since the ground does not get to this place. And immediately I did that. I did that. So yeah, voltage, no, it works. Yeah, and if you look at it here, yeah, it's working. It's working. So, and here is it on the board, and what I just explained using schematics. So yeah, see, yeah, can you see the jumper? Can you see the tiny this? Yeah, the jumper from here, from this CN2. Yeah, the connector for the for the screen. Okay, I connect to here. Here is the ground. You see the tiny stuff there. Okay, so connect to it, and it worked. So that is it. Right. So that is how the problem of this was solved. So aside from for the this thing, the sensor to break, okay, and here is the connector for the sensor. Yeah, so I make a jumper here for it. Okay, instead of before there was a cable from this capacitor, I run it back. So I run it behind. So I check here, I put it off, and I made a jumper here. So yeah, this is much better. Okay, so now what I've discovered on this board is that there could be a break between this charging IC and the sensor. Okay, the sensor, I have to remove this battery. Yeah, turns to white. Good. I have to remove this battery. So come to this back. Okay, and here is the sensor. Here is the sensor. Here, yeah, the sensor. Come to focus. Here is the sensor. Here. Good. All right, and here is our friend here. Okay, that was not opening before, so I made a jumper. It was not working because I've bypassed something, so it will not charge. Though the same will turn on, but it won't charge. But now the condition is perfect. Okay, so that is oh, my friend is twisting. Okay, all right, I have to unplug. Okay, straighten out. Okay, so okay, so number one, that is not the connection from here. That is pin number let's check. That is for the sensor. Is that pin number 3? Let me see, where are you? Okay, number 4, pin number 2 and 4. Yeah, 2 and 4 straight to the sensor. Pin to number 2 and 4. Okay, straight to the sensor. Okay, so it's either there's a breakage there. Now another thing I've discovered that it's possible that the ground here will be absent. Okay, the ground here would be disconnected. So I ran a ground from here to here. So here is another fault that I've also discovered on this system regarding charging problem. Okay, regarding charging problem. So for this condition regarding this IC, ACDET must be greater than 1.6. It must be 2.7 volts. There must be AC OK. Okay, there must be AC OK, and pin number 16, that is RGN, must be 6 volts. Now let's check. Let's since this is working, now let's take some readings. Let's take some readings. Zoom in. Good. Zoom in. Good. So let me plug in. plug. Yeah, it's on. Oh, I have to zoom out because of the multimeter. Okay, there you are. Oh, I have this space is too tiny. All right, let's work with this. Okay, shall we? Come on, my friend. It appears my battery, this battery is flat. Oh, dead. Oh. Put it up. The battery is dead. Multimeter. Let's see. Okay, let's try to manage this. Okay, this should give us approximate value. Should do the job for us. I'm not sure. Battery and this one too is low. I have to put it DC. DC. Yeah, let's use 20. 20 should work. What we are reading is far less than 20, so it should work. Oh, disconnect off. Okay, so first what you want to check, let's check is this positive. Okay, let me use this window parts because all right. This part is having problem. Okay. Pray this thing works. Oh. This probe is having problem. Let me okay. Let me press it down and use here. So the ACDET, that is pin number. So this is for the ACDET. Yeah, this part here. That is pin. ACDET is pin number. Is that not 6? Let me check. ACDET, yeah, pin number 6, and it comes here. So let's check. Oh, behave, my friend. Good. Yeah. Seems this is not working. Then put it in continuity. If you are going to beep, continuity, where are you? Can't say again. You beep? No. So it's not working. Not working. Not working. Oh, this is not good. Oh, bye bye. They're not useful. This one is going. Let me try to replace the battery. Okay. Right, so the battery has been replaced. Wow, come back. Nice. So new battery in. So let's plug in this power pack. Let's take some readings. Yeah. In. You can see the white light glowing there. So let's see. Let's see what it will give us. This is what, right? DC. So let's, okay, here is ACDET. It should be 2.7. You see that, right? 2.7. Yeah, this one here, they are AC okay. That is AC in. 2.99. Okay. This is without battery. No battery plugged in. All test again. AC okay. And pin number 16. Pin number 16. Pin number 16. Oh, let me check. I can't measure straight on the IC because my probe is much bigger. I don't have tiny probe. So let me measure from capacitor. Pin number 16. 16. So 16 is here. Pin number 16 comes straight here. So this should give is 6 volts. You see? Interesting, it's not 6.01, 6.1, just 6 volts. You see? 6 volts. It must be 6 volts. 6 volts exactly. Not 5.9. Haha. 6 volts. Good. And those are the crucial conditions. Okay? These are the crucial. Now let's check this. Maybe perhaps you are facing, maybe you are battling with one that here, ACDET here is, you are getting 1.6 volts. It's not to 2.7. Okay? So, now we have 1, 2, 3, 4 resistors. 2 down here are 1 mega ohms. 1 mega ohms, 1 mega ohms. This one is 750, another one is 2 something. Oh, it is 2 something, 1 something. K. Okay? So now let's check, let's read this spider first. Until this one comes in, there will be light here. 2.7. Yeah, this 2.7 is it. Here should be absent, 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 because now this is ground. Absent. Only this one is 0.5. You see, it's 0.55. Good. So that is it. So we have voltage here. Absent, absent, absent. We have here is 0.5 absent. So if yours is reading here, if it's reading here, automatically this will read. That means the problem. Check the ground. Maybe perhaps the ground has cut away from this leg. Then you make a jump from anywhere you like. It could be you can make a jump from here to here because here is ground. No, I think here is ground. From here to this place. Yeah. So that is all. So that's how this motherboard was fixed. Oh, let's read this part. Our friend at the back. Our friend at the back. The gateway. The gateway of light into the system. Yeah. So we have 19 here. Good. We have 19. Here is 4K. Okay, 4K should be 25. You see, 25.7. It comes and yeah, it enters. Okay, yeah, it comes here. Okay, then it opens up. The 19 volts supply into the system. Definitely, you see 19 volt here. 19.72, 71. Same thing with this. 7271. Yeah. All right. So that is it. So that is how to fix charging problem on this. 2 things, as I said earlier on, that I've discovered: a breakage between the IC, charging IC, and this friend here, this sensor. Okay. This sensor. Yeah. And here is another thing here. Okay, this one will be coming floating because ground has been cut away. So you make a jumper and now it will solve. Okay, so that is all.